So guys, in the previous diagram, when we drew this, we were discussing the derivation for. So in this lens formula derivation, what we have considered, we have considered an object AB, which is at a distance of how much? What will be the object distance, guys? Will this be the object distance? Will this be the image distance? And will this be the focal length? F, right? Yes or no? So we are just going to do that only. Can you see over here? These two triangles are similar. These two triangles are similar. So can I write from here a in this triangle? Can I write a dash b dash upon ab? Can you see this length upon that length is equals to ob upon ob dash? Oh, sorry, ob dash upon ob. Can I write this? Yes or no? Can I write this?
Yeah.
Similarly, here in this triangle, can I say OD and OF? Can I write? Oh, it's not D, it's P, right? We have considered it P. So we can write OP upon OF is equals to FB upon is equals to, right? Can I say this thing, guys? From this similarity, from this triangle, OP upon A dash B dash is equals to OF upon FB dash. Can I say this? If I can say this particular thing now, clearly see in the diagram, guys, OP and AB are equal to each other because this line AP is parallel to the principal axis. So here I can say AB and OP are equal, so I can replace. I can say this is AB upon OF. If this is AB upon OF, then I can again write it into two things. Can I do like this? A dash B dash upon AB is basically BF upon OF. Can I write it like this? Can I write it like this, guys? Hello?
Yes, sir.
Okay. FB dash, FB dash. है ना? This is B dash. So guys, see clearly over here. This was B dash, है ना? So OP upon OF is equals to A dash B dash upon B dash F. So OP was equals to AB, so I wrote it as that the same thing. And from here I rearrange this thing into this particular time, right? Now B F B dash F, this length. Can you see this length, guys? This length is equals to what? What is this length? Can I write B dash F as B dash O minus OF? Can I write it like this? So B dash O minus OF upon OF is basically this. So from this triangle we have done two things. And now what we have used over here, since AB is equals to OP and B dash F is equals to B dash O minus OF. So we have used these two things to make this equation, right? This is our equation number 1 and this is our equation number of 2. Can you see the left hand sides are equal? If the left hand sides are equal, the right hand side will also be equal. So this will be B dash O minus OF upon OF is equal to O B dash O upon BO. So can you see all the distances now are from the all the distances are now from the center. Can you see, guys? OB dash is basically the distance image, OB is basically the object distance, and OF is basically F, focal length. But please remember, we need to put them with sign because we are deriving a formula, right? So B dash O is the distance of image. Our image came to be at the right, so plus V. BO is basically where the object is, so minus U is equals to B dash O plus V minus OF is basically plus F divided by OF, which is again plus F. So can you say I have put it with a sign convention? When I solve it, will it be equals to minus of V by U will be equals to V minus F divided by F. Can I solve? Can you see over here this Vf minus Vf is equals to Uv minus Fu, right? And I can send this minus sign over here. So Fv is equals to Fu minus Uv, right? Now can I divide the whole equation by UVF? UVF. So basically this will become Fv upon UVF is equals to Fu upon UVF minus UV upon UVF, UV, FU, FU, FV, FV. So from here, can you see over here very clearly 1 by U is equals to 1 by V minus 1 by F, or from here I can rearrange this over that side. 1 by F is equals to 1 by V minus 1 by F. Okay, please note down the whole derivation. It's easy, but a little different than the previous one. So, lens, mirror, spherical lens, the one, it is easy to do with O, B, and F, but it's very difficult to do, using O, B, and F for this. So, anyways, please write it down and just give me 5 minutes. I'll be back. Guys, are you done?
Yes, sir.
Acha, guys, is there any app in which I can merge the two videos which are recorded for this lecture?
Not sure.
मेरे को पता करके बताओगे ना? Today I'll send it in two parts, no problem. But
All
tell
right.
me no, so I can upload the whole one continuous video of the whole lecture.
Okay, sir.
So anyways, so this was the derivation for lens formula, and from here we can derive for magnification as well. See, magnification formula is easy. Do you remember this? For lens. So by equation number 2, which was basically A dash B dash upon AB is equals to OB dash upon OB, right? A dash B dash is basically minus of HI, AB is basically plus HO is equals to OB dash, the image distance, plus V, and OB is basically minus U. So from here, can you see? Minus of HI, minus and minus sign will get cancelled. HI by HO is equals to V by U, and this is nothing but our magnification. From here we derive the magnification formula. Any doubt? Guys, any doubt?
No, sir.
ठीक है. So let's continue further questions. Find the focal length of the lenses below. Yes, please find out. Direct application of lens figures formula. Okay. So this lens is placed in air. It's having refractive index 3 by 2. This surface is 10 centimeter. This is 20 centimeter. So calculate the focal length 1 by f is equals to 1 by. Do you remember this was basically what mu 2 3 by 2 minus upon 1 minus 1 into 1 by r1. So conventions, positive this side, negative that side. So tell me, will r1 be positive or will r1 be negative? Please tell me guys fast.
R1 is positive.
R1 is positive, so R1 is plus 10, and R2, can you see R2 is curved towards left, right? So hence minus 20. You need to see where exactly it is curved. So if this curved uh, like this, then the radius center will lie somewhere over here, and hence this will be the radius. If it is
So we have to look from like one side only, yeah? Both the
yes,
lenses curvature.
matlab
Like like we either see from left or we either see from right,
ha,
no?
either see from left or either see from right.
Okay.
To look for curvature, you need to do this thing. So now you can solve. I think this is 3 by 2 minus 1 is basically 1 by 2, and this is 1 by 10 minus 1, this is 1 by 10 plus 1 by 20, which is basically how much? This is 10 into 20, or sorry, LCM is, this is 3 by 20, and this will be 1 by 2. So what is the final answer? F will be equals to, this is 1 by f, no? Don't forget to reciprocate. Answer. Similarly here, it will be 1 by f will be equals to, tell me, you will make the equation, I will not make the equation, tell me. 3 by 2 divided by 4 by 3 water minus 1 into 1 by, please tell me for the signs. R1 will be positive or R1 will be
R1
negative?
is negative.
R1 is negative, negative 10 centimeter, and R2 will be so
Positive.
plus 10. Is it clear? So 3 by 2 upon 4 by 3 is basically 9 by 8. So 9 by 8 minus 1, and this will be minus 1 by 10 minus 1 by 10. So what is minus 1 by 10 minus 1 by 10 twice? So this will be equals to 1 by 8 into minus 2 by 10. And can you see the answer is coming negative? Answer. Is it clear?
Yes, sir.
चलिए, ठीक है. So this is how you apply the Lensmaker's formula. Next question. These are very important types. A focal length of a thin lens in air is 10 centimeter. Now this lens is dipped in a medium of refractive index mu is equals to 2. Okay.
Yes,
Right.
sir.
So the question is, अच्छा हाँ, mu equals to 2 and dipped in a medium of refractive index mu equals to 2. Now find the focal length of the lens in this medium if the refractive index of lens is 3 by 2. So basically the refractive index of lens is given how much? 3 by 2. Initially it was in air and then it was in medium of mu equals to 2, right? So initially it was in air and then it was medium in air. Now tell me this particular thing, guys. Acha, let's try to do this thing. This is mu naught and this is mu, and the focal length is f naught. No value is given to you. Medium of the lens is given to be mu naught. Initially it was in air and then it in a medium of refractive index mu. Then find out how will you do. So see, whenever this type of questions are very important, because it can come in your school as well as your competitive exams, always, because I've seen this type of questions many times. In air, if I want to calculate, so in air, will it be like 1 by f naught? Acha, is what kind of lens? Is it given what kind of lens it is?
No, sir.
No, right? It's just a thin lens given, nothing else is given. It convex hai ki concave hai, so don't use sign convention. If you use sign convention, you will get in trouble, hai na? So first case when it was in air, it was like this scene. Suppose this is the cell, this is the lens, and basically this has mu naught and this medium is mu. So can I write 1 by f naught is basically mu naught upon mu minus 1 into 1 by initially it was in air, right?
Yes, sir.
So here the medium will be, this is air, so this will be upon 1. 1 by r1 minus 1 by r2. Let whatever r1 and r2 is there, let it be there, no problem. Now when you place it in medium, what happens, guys? When you place it in medium, then what happens? This new focal length f dash, it becomes mu naught upon mu minus 1. Does the radius change when you place it in some other medium? Does the radius change?
No.
No.
So the radius are still going to be 1 by r1, 1 by r2, right? Sign convention still same, everything same. So can you see, you can just divide these two equations. Divide 1 by 2. If I divide 1 by 2, then I get 1 by f naught divided by 1 upon f dash is equals to mu naught upon 1 minus 1, and this becomes mu naught upon mu minus 1. Yes or no? So basically this is your f dash upon f naught. This goes up, this goes this. So they get multiplied like this, and from here f dash will be equals to f naught into this will be, what will be this, mu naught minus 1, right? Yes or no? Divided by, this will become mu naught minus mu, and this will be in the denominator, it will go and multiply up, so it will become like this. So that's the final answer. Okay, so depending upon mu naught and mu, even the nature can change. The one question which I was giving you, I changed the nature as well. Okay, so initially if the focal length was positive, then I placed it in such a way, I arranged the question in such a way that it will come negative. The data which I gave you was for f dash becomes negative, right? So either even the nature will change. So these type of questions are important, but anyways, is it clear? Any doubt in this, guys? Any doubt in this? Hello. Hmm. Combination of lens will be here. Anyways, next question, guys. There is a lens and which is placed in front of a spherical mirror. So see the question very carefully. A converging lens and a converging mirror with their principal axis or optical axis coinciding, that implies both have the same principal axis. They both are placed at 40 centimeter above from each other. 40 centimeter apart from each other. Now there is a point source S which is at a distance of 12 centimeter from the lens. A point source S is placed on the principal axis at a distance of 12 centimeter from the lens is shown. Up the question it is found that it is found that the final beam of light comes out parallel to the principal axis after reflection from mirror. So after getting reflected from the mirror, the light rays come parallel to the principal axis after reflection from the mirror. The question is, if the focal length of a lens is 15 centimeter, then find the focal length of mirror. So this is your question, very important. The very nice question. Try to do it. Yes, guys, how will you do this? They have given the focal length of the lens is how much? 15 centimeter. Then they have asked what is the focal length of the mirror. That is the question. Sir, how will we do this question? Are very easy. Whenever two or more optical instruments are involved, see, first of all, for the lens, Can anyone tell me if we take this as our convention, positive, negative? So for the lens, what is the object distance from the lens? This is the figure in front of you. Where is the object located with respect to lens? Hello, guys. Where is the object located with respect to lens? Can you see 12 centimeter towards left?
minus 12 centimeter.
So minus 12 centimeter. What is the focal length of this lens? What is the focal length? Guys, this meeting will again end in 10 minutes. Well, no need to join after that. It's okay. So FL is basically 15 centimeter. Okay. So can you see over here, this focal length will lie towards the right? Yes or no? Focal length of a convex lens, positive. Yes or no? So it will be plus 15 centimeter.
Yeah.
Where will the image form? So 1 by F is equals to 1 by V minus 1 by U. So 1 by V basically 1 by F plus 1 by U, which will be 1 by plus 15 plus minus 12. So this will be 1 by 15 minus 1 by 12. And this will be how much? 15 and 12. What is the LCM? 60. Right? Yes or no? This comes 4
Yes, sir.
times. This comes 5 times. So basically, what is the final answer from here? V is equals to minus of 60 centimeter. Yes or no? So where is the image formed due to the lens? Due to the lens, the image forms somewhere over here. I dash. Sir, why are you naming it as I dash? Because, guys, I dash will act as an object for the mirror now. Virtual object that too. So for the mirror, I dash acts as object for mirror, and they have said very clearly कि after the reflection the reflected ray becomes, guys, do you remember? They have said very clearly कि after the reflection the reflected rays becomes parallel. So the object is placed at minus 100 centimeter now. How, sir? Do you remember? This distance was found out to be 60 centimeter according to our calculations. This was 40 centimeter. So can you see from the pole of the mirror, this is at 100 centimeter towards left. So I've written it like this. Where is the image formed? The image is formed at infinity, and you need to find the focal length. So 1 by F. Although, guys, no need to apply the formula. We know this particular thing. If the image is formed at infinity, that implies the object is at,
Focus.
if image forms at infinity. So hence, what will be the focal length of this lens? Sorry, what will be the focal length of the mirror? That will be equals to 100 centimeter. Answer. Is it clear? Any doubt? Guys,
No,
any
sir.
doubt? Okay. So I'll give you 2 more questions as homework so that you can do it. There is this lens, and there is one more lens, a concave lens and a convex lens are placed like this. Both have the same optical axis. Now the question is, I incident a parallel beam of light. A parallel beam of light is incidented on it of diameter d, which is equals to 5 mm. So a parallel beam of light of diameter 5 mm is given to you. The separation between these two is given to you 10 centimeter. And a convex lens of focal length is given to you. Focal length 20 centimeter and a concave lens of focal length 10 centimeter are placed at a 10 centimeter distance apart with their principal beam of light angle. Now the question is, prove that the emergent beam will basically will, can you see over here, these this is the convex lens, right? So this convex lens will try to converge light rays, but when they will fall on this particular thing, it will diverge the light ray, right? So the question is, prove that the emergent ray is parallel, or it's a is the parallel beam of light, and also find its diameter. Try to do this question. This question is easy if you will apply the logic of ki acha, if the image, this is a parallel beam of light, then what will happen? Hint: use basic knowledge of location of image. And the diameter is found by similarity of triangles. So I am giving you how to solve it. Try to apply this knowledge. Anyways, next question for homework. There is a huge spherical mirror. This is the principal axis of the mirror, and I have a lens. भाई ये गेट बंद कर देना है प्लीज. So can you see, guys, over here, the distance between the optical center of this lens and the pole of the mirror is basically 5 centimeter, very nearby to each other. The question is, a diverging lens of focal length 20 centimeter is placed coaxially at a distance of 5 centimeter towards left of a converging mirror of focal length 10 centimeter. So basically the whole setup. Now the question is, where should an object be placed towards left of the lens so that a real image is formed on the object itself. But basically you need to assume that, let us say, this is where the object is placed. Let's name the object as A, and the object is placed at a distance of x away. So basically what will happen, whatever light rays will go from here, they will get reflected, diverged away from each other, right? But after reflection from here, the image shall again form where? The image shall form exactly, matlab, can you see over here, the image shall come back to this particular thing, form on this object itself. But फिर भी मैं एक हिंट लिख देता हूँ, और हिंट की जगह पे एक कॉन्सेप्ट भी आ जाएगा. ऑलवेज रिमेंबर, अरे भाई ये गेट बंद कर दे यार, sorry. So the concept is over here कि whenever an object is, oh sorry, image has to be formed after reflection from a mirror. So whenever, guys, you can see this particular system, this system has a lens and a mirror. That does not matter, right? the what matters is basically there should be presence of a mirror. There should be either a concave mirror, convex mirror, or basically a plane mirror as well. No, doesn't matter. If there is a mirror, and if you are saying ki you want to form the image, the final image on the object itself. So whenever an image has to be formed after reflection from a mirror on the object itself, then that object ऐसा कब होता है when